All right, problem number 2 asks us to consider the Venn diagram below and find the number of elements in A union B complement. I'll show this in 2 different ways. The first way is relatively intuitive. Let's identify the set A union B. Right, let's identify the set A union B. A union B, the union means just join everything together. Everything that's in A, join that up with everything that's in B. Don't double count anything, right? But everything that's in A, join that with everything that's in B. So if we're looking at A, here's set A, the circle here. Here's set B. Every value that's in here, that's A union B. So 9, 1, 4, 6, 3, 2. That's my A union B. But this wants the complement of that. So this problem is asking for the number of elements in everything else. Everything outside of this A union B here. Everything outside of this set. Everything outside of here. So that's literally 18, the number that's only in C, not in A or B, only in C. That's 18. Plus the number that's in none of these 3 sets. 18 and 10, that's 28. That's the number of elements in A union B complement. So that's one way to think about it. Another way is a way method the book uses. I'm going to number each of these regions. Here's 1, 2, 3, 4, 5, 6, 7. Number them in a different color so we can kind of differentiate. And we're going to parse out this number of elements in A union B complement. Okay, so we're looking for the number of elements in A union B. So I'll set this up as A union B and then the complement of that. Number of elements in A, in set A. So I'm looking for the regions, right? I'm not thinking about the numbers inside here that are given to us in the problem. I'm thinking about the regions. So which regions are in the set A? Which regions are in the set A? And I'll use braces to enclose that. So the regions in set A, 2, 3, 4, 5. That's set A, this circle here. So 2, 3, 4, 5. Those regions I'm talking about here. Those are the regions in set A. And I want the union of that with the regions that are in set B. Set B is the circle here. So the regions in set B, 3, 4, 7, 8. So I'm treating this like a problem where I'm just determining the sets, listing the elements in a set, not necessarily the number. I'm approaching this from a different perspective. So these are the regions in set A. These are the regions in set B. I want the union of those 2 sets. So the union would be just everything together. If this asks for the intersection, then I would see what they have in common. But this wants the union, so 2, 3, 4, 5. Joined up with, we've got 3 and 4 already, joined up with 7, 8. This is the union. These are the regions in the union of A and B. So 2, 3, 4, 5, 7, 8. That's the union. Those are the regions in the union. Now this asks for the complement. So literally we want everything else. Every other region. What's missing? Everything that's missing from the set 1, 2, 3, 4, 5, 6, 7, 8. There's 8 regions here. Which ones are missing? Region 1 is missing. And region 6 is missing. So those are the regions 1 and 6. Regions 1 and 6. The number of elements in those regions. The number of elements in region 1 is 10. It's outside here. The number of elements in region 6 is 18. So 10 plus 18 equals 28, which is exactly what we got here. It's another way to think about it. That can also work if this approach doesn't work too well for you. I'll do both methods again in problem 3.